Alright, this is going to be the last update you see of the boost controller from me, for at least for this particular unit. I made a Facebook post about this. I ended up breaking down. I checked this out originally and found out that the 30 hertz worth of pulse width frequency was too much for my boost controller, or my 4-port Mac valve. So I ended up breaking down and posting the code on the Arduino forum with a question of how I could shorten it. And a guy, I believe his username is CattleDog, commented back with the fix for what I needed. I still have the post up because I'm trying to figure out the extra settings there are on this line of code, but it got me to where I was able to reduce the pulse width to 15 hertz, and this solenoid likes it. Before, when I checked it, its working frequency was somewhere between 25% duty cycle and 50% duty cycle. So you had 25% worth of knob control before you went from fully closed to fully open, or no wastegate to all the boost that the motor can make. So because of that, I had to modify the code. Got that figured out this morning, and I just ran through a test, and I'm going to show you what it's doing. So I'm going to power my oscilloscope back up. Give me a second here. Let's see, set this up for there. So, see if I can zoom this in. It's set to 10 milliseconds of division and 5 volts of division. So, we have the boost controller here, and you've already seen the power up settings. So the sucker's powered up right now off 12 volts, and you can see the current duty cycle is 0. And I have it using 2 sets of test leads, one for power and another set to bring it into my boost controller wiring, which it's a 4-port Mac valve right here. Let me zoom in on this sucker here. There you go. So 4-port Mac valve is what I'm using on my Firebird, and that's what I'm testing with. So I'm going to set this up to, I'm going to try to do this with the camera in hand. So I'm going to set this up to, like, say 40%. We'll go 40. So 40%. I don't know if you can hear that clicking. So we'll set this up right here. Just probing this with that. And there's the duty cycle of that valve. If this will focus. There we go. So, and I found the lowest you can go, I think it's like 14. Or at least audibly. I'm not using my stethoscope right at the moment. But I think it's like 14 is the lowest. And you can feel it clicking very lightly. And then you can take this up. It's like 70% is the max. Yeah, 68 to 70. And you can feel it clicking right there. Take it right up to 70. And it's still clicking at 70, so we'll take a little higher. Take it to 75. I still feel it clicking, but it's not a lot. So this will be the whole R&D to see where it is adjustable to, like its working range. But you should have somewhere around 14 to 15% to 70-ish percent, 75. So that's what, 60% worth of duty cycle that it's going to be working at. And I mean, right now it's set to 75. I'll probe it real quick and show you. As you can see, it's still giving it a pulse width. And this isn't inverted because I have it, the oscilloscope set backwards, so I'm actually probing the positive side. So even though it looks like the on port's only a little bit, I'm probing the ground, so it's actually, I mean, that signal's inverted. So the bottom arrow is the part that's the highest percent duty cycle, because it's duty cycling the ground. But yeah, so far everything's working the way it should. So, next up is going to be, I'm shipping it this coming week to Matt Happel. He is going to put it on the Colorado, and I'm sure he'll be posting videos about it. Thank you for watching this update, and just to let you guys know, also, my next line of videos you're going to be seeing coming out with my Arduino testing is I am finally getting back onto my transmission controller. I started in on it while I was waiting for help on the code with this boost controller. I have the code pretty much set up. I've got to switch from an RPM input to a speedometer input, and because of the small engine dyno work, I have the circuitry I need for the speedometer input, or at least I believe I do, and the circuitry to make it, or the coding to make it work. So you should be seeing that very soon once the temperature starts rising, because right now it's like 20 some degrees in my garage and I don't really feel like working out here. So I'm going to be working on the code and getting it in a box and getting it situated. Once I get that done and it functional on the bench, I am going to wire it in this car and see what it does. So stay tuned for updates about that, and stay tuned for boost controller updates. I am probably going to make a couple more units once this one's tested on his truck, and play with advanced inputs and stuff like that. So just stay tuned, and thank you for watching. If you like these videos, please subscribe. I don't know if you've seen the YouTube stuff lately, but anyone with under 1,000 subscribers, I don't know if they're going to reduce the content out or what's going on, but if you think this video is worthy of a subscription, please subscribe, and we thank you for watching. Have a good day.